Sorry about that. For this second bit, I'm going to do the same thing for each of those pieces. So I'm going to take 3 and, oh, sorry, it's glitching out here. Okay, 3 and raise that to the third power. This is the second expression now. A to the fifth, raise it to the third power, and b cubed, and raise it to the third power. And I'm going to write it below, and then I'll erase it when we're done, just so that we can get the results of this. So below, we have 2 to the third is 8. A to the fifth raised to the third is a to the 15th, power of a power, we multiply them. B to the fifth raised to the third is b to the 15th as well. We're going to do that times 3 cubed, which is 27. A to the fifth raised to the third is a to the 15th, and b to the third raised to the third is b to the 9th. Now when we multiply them together, we multiply the coefficients. 8 times 27, I'll do that down here. 27 times 8, 6, carry the 5. 8 times 2 is 16, plus 5, 21. 216 is our coefficient. And then we multiply a to the 15th times a to the 15th, which is a to the 30th. And we multiply b to the 15th times b to the 9th, and we get b to the 24th. And if we then look for that expression, we see that we find that in answer A. Okay? So I'm going to erase all this just because we need the space to do the rest of these problems. Okay, so that is the first one. Looking at the second one, we are dividing q to the 33 fourths divided by q to the 8th. So what we really have is q to the 33 fourths minus 8. Like that. That will be the exponent if we can resolve what does that equal. Okay, so let's calculate this over here. What is 33 over 4 minus 8? Well, let's turn the 8 into over fourths, because in order to subtract, we need to have this common denominator. So how many fourths equals 8? Well, if we do 8 times 4, we get 32. Right? 4 goes into 32 8 times. That's why that's equal to 8. So then we can say, okay, now that we've got fourths, we can essentially say we're going to do that, the numerators, 33 minus 32, all over a single denominator of 4. And what does that work out to be? That works out to be 1/4. So then we've got, as an answer, q to the 1/4 power. So essentially with this one, the trick here is to subtract these numbers, these two exponents. And what do we do to do that? We need to get a common denominator, and that's what we did here. So we've got an answer of q to the 1/4. And when we look for that, we find it right there. A. Okay. Now, we'll continue on with this. When you have a fractional base, like we do here, this is a fractional base raised to the third power, we can give that exponent to the numerator and the denominator separately. So we have 4k to the 4th raised to the third over 7c cubed raised to the third. And then what does that look like? We give the coefficient, that exponent, 4 to the third. Sorry, having a little bit of glitchiness. Let me erase it and just rewrite it. 4 to the third times k to the 4th to the third over 7 to the third times c to the third to the third. And then on the top, 4 to the third is 64. And k to the fourth to the third, we're power to a power, we multiply them, k to the 12th. On the bottom, 7 cubed, 343. I just happen to know that multiplication fact. 7 times 7 is 49, 49. And actually, let me just show you the mental trick of this, okay? 7 times 7 is 49. So if you're doing 49 times 7 to get it to the third power, what you really can imagine this as being 50 minus 1, all multiplied by 7, okay? And what's 50 times 7? 350. Take away 1 times 7, or 7. So we really are saying we're 1 less than 50 times 7 if we're doing 49 times 7. 50 times 7 is 350. So we go 7 less than that, and 7 less than that, 343. So we get on the bottom there. And then c to the third raised to the third is c to the 9th. And that's what we should have as an answer. And so let me erase this, and let's look for that answer in the answer choices. 64k to the 12th over 343, c to the 9th. Great. Okay. Now, there's multiple ways that we can approach this last one. The first thing that I'm going to do is, because it says parentheses and then exponents, right? In order of operations, first do parentheses. So what I'm going to first do is I'm going to simplify what's in parentheses. I'm going to say, okay, we're going to still keep it to the -3 power. And then on the top, we've got m to the -1 times n to the 5th, and that is m to the 4th. And we put that over m to the -2. Okay? Continuing to resolve it, we've now got in parentheses m to the 4th divided by m to the -2. And whenever you divide two expressions with the same base, two powers of the same base, we subtract the exponents. So we essentially have m to the 4 minus -2 raised to the -3rd, or m to the 6th raised to the -3. And then, of course, I can just do that and say power of power, we multiply m to the -18, which, of course, since there's a negative there, we're going to move that to the bottom and say it's 1 over m to the 18th. That's our answer, and when we look for that, we find it there in B. Oops, sorry, I'm in the wrong bit there. B. Okay, those are all of our answers. Hopefully each one of those makes